Let's take a look at reading pseudocode functions. And specifically, we're looking at examples that have functions that call other functions. So for example, let's start with double 5 over here. Actually, let me make my colors clearer. So we're gonna start with double 5 because we're gonna be doing this twice because we're calling double a couple different times. Okay, so in this case, my x is going to be 5. And I'm going to substitute it in here for 2 times x. So 2 times 5 is going to equal 10. Okay, great. So far, so good. Let's go on to the next one. Let's do this one in blue. So now I'm going to do double 4. Okay, so first off, we're going to say 4 times 2. That equals 8. And then I'm going to come back and I'm going to take that value, right? So 8 is what we have here. Now I'm going to take that value and substitute it again, and multiply by 2 again, and I'm going to get 16. Now I'm writing this out just next to the function calls, but really for a bigger example, as we'll see down below for question number 2, I really like to use a manual walkthrough table where I systematically write down every call and what it returns. And so the final example we have is creating a square of pluses here. Okay, and so let's come up here. So we're going to make a plus, and our n is 4. So for I equals 0, I less than n, I plus plus. I'm going to print my string, which is plus, times n. This is Python syntax because Python allows you to multiply strings by a number, and it repeats it the number times. So I'm going to write out 4 pluses to represent that one line. And then I have this for loop up here, which can go from I equals 0 to I less than n. So this is also going to repeat 4 times. So I'm going to be making 4 rows of these pluses. Sorry, I'm jumping up even though it's not the order the computer would print them, just because I'm running out of space here. Okay. So, okay, awesome. So let's go on to the second example. And I highly urge you, if you haven't done so already, to take a moment and try these examples. Pause this video. I'll wait. I'll still be here. Try it yourself. When you try it yourself, you have an opportunity to test your knowledge and find out where you need to work more, right? So if you just watch this, you've missed an opportunity to test your knowledge. Now, if you've tried it and you're really unsure and you need to watch it to move forward, that's absolutely fine. What I'd recommend you do is take this example, type it in your favorite programming language, and then change it and see if you can predict the output. So the good news is that you can generate infinitely many different examples to test yourself until you've really mastered the concept. Okay, so we'll start off, we're on green, so we'll just keep with green. And we want to print H3. Now, in this example, I'm going to have to create a manual walkthrough table. I can see it already because H3 over here, H is going to be calling functions F, which is going to be calling functions G. So I'm going to be all over the place here. So I'm going to go ahead and make one of my manual walkthrough tables. And when I do that, I always write down a method call and then what it returns. So my method call is going to be H3. And I don't know exactly what it returns, but if I follow through h of x, so I'm going to be putting 3 in here, 3 mod 2. 3 mod 2 is going to equal 1. So if 3 mod 2 equals 1, I'm going to be down here. I'm going to say f of 3 plus 3. Now you might be saying, hey, wait a minute, whoa, this equals 1 wasn't there. Well, it just so happens that if your result is 0, that is the only case that will drive the else. So really what we can say is this else is equals 0. If you have something, anything other than 0 as a result, it's going to be here. This is going to be a non-zero. X mod 2. So any other remainder besides 0 is going to have the if be positive. And this is just residual leftover from older languages like C, where you can just say if some number, and if the number is 0, it's false, and if it's any other number, positive or negative, it's true. So this is the just a historic mode of working with ifs. Okay, so let's go back to our manual walkthrough table. Method call is h3. It's going to return f of 3 plus 3. I don't know what that equals. So I'm going to have to keep going. All right, so let's go down to f of 3. So I'm going to substitute 3 in here. Oh, first let me do my f of 3 here. Okay, so x is going to be reduced to 2. And then I'm going to return g of 2 plus 1. Still don't know what that is. So now I'm going to have to call g of 2. I substitute in 2 in here. 2 times 2 equals 4. Yes, woohoo! Now I can start passing things in. So 4 plus 1 is 5. And 5 plus 3 is going to be 8. Awesome. Okay, so let's keep going. Let's move on. We'll go to our blue here. We'll keep the same manual walkthrough table, but we're going to now focus on printing H4. Oh, before I do that, I should make this complete. We are returning 8 here. Okay. Now moving on to H of 4. So I don't know what H of 4 is, so I'm just going to write it down and come over here and assume my X is 4. All right. So 4 mod 2, I'm going to be in my else because 4 mod 2 is 0. And that is going to return f of f, and my x this time is 4. Now I don't know what that means. So I'm going to have to first, I can't solve this outside f. So I'm going to start on the inside f of 4. F of 4 is going to return g of 3 plus 1, which I also don't know what that is going to give. So I'm going to write down g of 3, and now I'm going to pop that in there, and I get 6. Yes, okay. So I have a starting point. So now I can substitute back in to the previous line. So g of 3 is 6, that equals 7. All right, so now I have a clue. F of 4 is 7. Now I need to figure out what f of 7 is. Okay, I don't know what f of 7 is, so I'm going to keep going. F of 7 is going to be g of 6 plus 1. G of 6 is going to be, let's see, we're going to plug that in. It's going to give us 12. And so we're going to get 13. And I plug that in here. And I get 13. And so this is the systematic approach that I follow to answer all of these questions. Okay, we've got one more. Let's see if we can fit it in. All right, H of 5. Let's see if we can fit this with my big handwriting. Okay, so we've got H of 5. I'm going to go over here. Now my X is 5. 5 mod 2 equals 1, so I'm going to be over here again. You might notice a pattern between even and odd. So F of 5 plus 5. Well, I don't know what F of 5 is. Okay, let's try this again. F of 5 is going to be G of 4 plus 1. I don't know what G of 4 is. So now I come down here. I plug in 4. 4 times 2 is 8. Yes, finally. Then I start substituting in. And I get, what is it, 14, I believe? I get 8, 13, and finally 14 is my number. So this is the process I use to walk through any function call based problem, whether it's recursion, as we'll get to soon if you're not there already, or any other functions that call themselves. And again, I urge you, if you had to watch this video to walk through these, that is absolutely fine. Learning in this class is a process. So now that you've learned this method, test it. Make sure you've mastered it. Take an example. Type it up in code that looks similar to this. Have a couple different functions. Have a couple if and else's. Put it into your code. Don't run it. Don't run it. Try to walk through it yourself and see if you can anticipate the answer that your computer will give you.